All right, guys, are there any questions on the assignments before we start today's lesson? What we're doing today is synthetic division. More students like this than long division. When we work with synthetic division, what we're dividing by, we solve it for x, or really, because we're just going to mainly deal with synthetic division, where what we're dividing by, the divisor, if I remember that correctly, we're going to solve it for x. Now, we can do this, and we'll show one at the end, where we have what we're dividing the bigger polynomial by is not a linear function, where the biggest degree or the biggest exponent is 1. We can do it with 2, 3, and so on. But for those, we always solve it for the variable with the biggest exponent. Now, if the leading coefficient is not 1, we're going to have to divide by that number. Okay. We're going to move on and do the first one, because this is going to make a lot more sense if we just work through it than me trying to put out all the steps. So you can rewrite the steps if you want, but when we look at this here, the first thing we want to do is solve what we're dividing this polynomial by for the variable. So here we have m minus 3, yes? So we want to set it to equal to 0 and solve for m. So what would I need to do to solve this for m? Okay. This is the first step. We solve it for m. So we have m equals 3. Okay? We good with this so far? Now we're going to set this up. Now to set this up, the first thing we draw is what I call cubbyhole. Just a little cubby. Okay? And a line. Okay. We all got that set up, yes? Cubby, line. What goes inside the cubbyhole is what we solve for m. So it's going to be 3. Okay? We good with this so far? Now going across the top, we're going to take all of the coefficients of the polynomial that's being divided. And if there's any that are missing, we put in a 0 for each one of those. So the biggest one we have is m to the third, and the number in front of it is? Number in front of mq, you're good, is 1. Then the next number is what? Negative 13. The number after that is? And the last number is? Okay. We have this set up so far, yes? So we're good with everything so far? Yes? Okay. Now to start this process off, the first thing we do is drop the first number. We bring it down. Okay. Next thing we're going to do is we're going to say 3 times that number there. I wouldn't draw the arrows because I'm going to put them in and then erase as we go because there's going to be a lot of arrows. So we'll do 3 times 1, which is 3. Okay? We take that 3 and put it under the next number, which is our 13. We good with this here so far? Add straight down. Negative 13 plus 3. Negative 10. So this one here, we're just adding straight down. Negative 10 plus 3 is, or negative 13 plus 3 is negative 10. Okay? We good with this so far? Okay. Well, I'm going to keep all the arrows because this is just going to start getting to be a little bit of a mess here in a second. Because now what we're going to do is 3 times negative 10. Three times negative 10 is? And we put that under the next number. Then we add straight down. 24 plus negative 30 is negative 6. We multiply it by 3. 6 is add straight down. Do we have any numbers after that? Okay, so we stop there. Questions on this so far? Okay. At this point, we don't have any variables put in. We've done, this is the entire process for dividing. We just have to put the variables back. What I always do is I always box the last number under that bar. I always box the last number. Because depending on what we're dividing, since we have m minus 3, there's only going to be one number for the remainder. And that last number is going to be the remainder. Now we go back with the variables. So the number immediately to the left of it is the constant term, the number without a variable. Or really what we're saying, you don't have to write this. This here is really going to be m to the 0. Anything to the 0 power is 1. So we're just saying negative 6 times 1. So really that's not included. The number after it, negative 10, is going to be m to the first. And then 1 is going to be m to the. So really what we have is m squared minus you have finished synthetic division. That's it.
I feel like it's like a lot more crazy than long division, because long division is just confusing, but long division is so long.
Yes, this is the exact same thing as long division. It's just a same version, same things we're doing, but just in a more simpler and condensed way. Same type process, because you would see all of these exact same numbers with long division. This is just another way to look at it, and a little bit easier way to do it. Questions on this here? So let's look at another one. Wow. Okay. That's a little bit better. Not as blurred. Yeah. So, first thing we want. Wow.
Sorry, I don't know why.
So, yeah, it's switching between two different versions of the same. So we have v plus 4 is equal to 0. So we need to solve this for v. That's the first thing we need to do. So we'd subtract 4. Cubby hole and a line. Yes, we would put negative 4 in the cubby hole. So we good with everything so far? Getting the number in the cubby hole, setting it up. So let's do the numbers across the top. So our first number would be 8, and then 32, and then. So we have 8 is for v to the 5th, yes? 32 is for v to the 4th. What's the next one we need? V to the do we have v to the third?
0.
So v to the third would be 0.
To the second, it also 0.
V to the second is also 0.
20.
Because we need every one. So we started out with v to the fifth, so I will need a number for v to the fifth, v to the fourth, v to the third, v squared, v, and our constant term. We have to have them all. Now at this point here, this one's actually going to work out to be very nice. Because we're going to do the same steps. Negative 4 times 8 is, well, 8 times 2 is 16. 16 and 16 is 32. So we'll put negative 32 under the next number, which is 32. What's 32 plus negative 32? Okay. Then we'll do the same thing, negative 4 times 0. 0 plus 0. Negative 4 times 0 is 0. 0 plus 0 is 0. Negative 4 times 0 is,
So they're just all 0?
now 5 plus 0 is 5. Okay. Then we'll do negative 4 times 5, which is negative 20. And we'll put it under the 20. And again, since we've made it all the way to the end, I boxed the last number as a reminder that for this one here, it is the remainder. Because since what we're dividing, our v plus 4, we have 2 terms, so the remainder is only going to have 1. If it had 3 terms, v squared plus v plus 4, our remainder would have 2. Okay? So 5 would be our constant term. The next one would be v. Then we'd have v squared, v cubed, and v to the fourth. Because the number immediately to the left will not have a variable, then it would be v squared, v cubed. We go up by 1. Well,
So then it'd just be 8 plus
8v to the fourth plus, because 0, yeah, because we have plus, 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 because that's 0, that's 0, that's 0. So all we have left is these. That's it. Questions on this here? Ready for the next one? Okay. I'm going to have to fix all these slides. So, yep. Now, this one here, unlike the rest, 3x we have instead of x, yes? Well, if we look at long division, we're not going to do the whole process. 3x to the third minus 4x squared going on. And here we have 3x minus 1. Because what I want to look at is this here. Because when we did this with long division, our first thing that we were asking is what times 3x gives us 3x to the third? Because, well, 3 times 1 would give us 3, yes? 1 times x will give us x cubed, x squared. So our first number, part of the solution should be x squared. So with synthetic division, our first number that we should have should be 1. Because when we fill the variables back in, it's going to be 1, yes? So if I solve this for x, let's do that. 3x minus 1 equals 0. Well, the first thing we would do is add 1 to both sides, telling us 3x is equal to 1. We'll have to divide by 3, telling us x is 1/3, yes? Now when we set this up, we'll have the cubby hole and a line. And inside here is going to be 1/3, yes? Now, watch this here so you don't have to erase. Because here we have 3 first, yes? Well, our first thing is we would drop it down, and we'd have 3. So don't write that yet. What was the number that we had for our solution doing long division? That we said we started out with is just x squared, 1x squared, yes? What is the synthetic division telling us our first number is going to be? That doesn't line up, does it? Because anytime the number in front of the biggest exponent or biggest variable that's in the divisor is a number other than 1, we're essentially going to have to divide. We could have started off in having to divide everything by that number. So we still get 1/3. 1/3 is still correct. But our polynomial here, and you can write this above it, I'm going to write it below it because I don't have the space above. Well, 3x cubed divided by 3 is just going to be x to the third. Does 4 divide by 3 nicely? No. So we'll leave it as 4/3 x squared. 17 divide by it nicely, 17/3 x plus 2. So you could write that above it or below it, but whenever we have the biggest variable in the divisor is not 1, we have to divide everything by whatever that number is. So we end up with this here, x cubed minus 4/3 x squared minus 17/3 x plus 2. So now we can fill those in. So our first number would be 1. The next one would be negative 4/3. The number after that is negative 17/3, and our last number is 2. But now when we drop the 1, or drop the first number, we do get 1, which does match up with the long division, yes? Because it should be 1x squared. All right, I don't need that anymore. Now we're going to do the exact same process. So we'll do 1/3 times 1, which is 1/3. Then we'll add straight down, negative 4/3 plus 1/3. You can do that in a calculator. The denominators are the same, yes? So we can add the numerators. Negative 4 plus 1 is negative 1. Then we multiply again. 1/3 times negative 1. Which will be negative 1/3. Questions? We good? We'll add straight down. Negative 17/3 plus negative 1/3 or minus 1/3. Denominators are the same. Negative 17 minus 1 is negative 18, which gives me negative 6. Because we multiply again by 1/3. What's 1/3 times negative 6? 1/3 times negative 1 is negative 1/3. Yes. And then we have 1/3 times negative 6, which would be negative 6/3, which is and that would be 0. So for this here, the remainder is 0. We can fill the variables back in. The number to the immediate left of it, the negative 6, is just going to be negative 6. Then we would have x, and then we would have x squared. So our answer is x squared minus x minus 6. Question? And a lot of this calculations, a lot of this here are multiplying. We could do all that in the calculator. We don't have to do that out by hand, because we could have done 1/3 times 1, which gave us 1/3, plus -4/3 gives us -1, times 1/3 gave us -1/3, plus -17/3, enter, gave us -6, times 1/3 gave us -2, plus 2 gave us 0. I have a feeling this one will give us a remainder. So with this here, the first thing we want to do is solve this for x. So if we solve this for x, we would subtract 1 from both sides, telling us x is -1. So we whole line. And across the top, we would have 3, -2, 2, -5. And we would bring down the 3. So we would do -1 times 3, which is -3. Then we would add straight down -2 plus -3 is -5. Then we'd multiply again, -1 times 5, -5 is 5. 2 plus 5 is, then we would do -1 times 7, which is -7. Then we would add straight down, which in this case is not 0, it is -12. And we box it, which tells me -12 is the remainder. Then we would have 7, which is positive. Then we'd have -5 would be with x, and 3 would be with x squared. Yes? So if we wrote this back out, we would have 3x squared minus 5x plus 7 plus over, what are we dividing this by? What do we actually? Yeah, just like before. Now we could write this in a different way. Because I could pull the negative out of the numerator and put it out front. So say minus 12 over x plus 1 is the same as saying plus -12 over x plus 1. They're the same thing. Any questions on this here? Do we need to see another example using synthetic division? We'll come back to this one. So here's our next example. Evaluate a polynomial. Use synthetic division to evaluate this here. Well, there is something that's nice. They already gave us x is equal to -4, yes? It is, because that means we can just plug -4 into the cubbyhole. We already solved for it. Now the numbers going across the top are 5, -1, 13, and 29. We bring down the 5. We'll do -4 times 5 first, which is -20. And if we add straight down, -1 plus -20 is -21. You're good. then negative 4 times negative 21. Negative and negative make a positive. 4 times 1 is 4. 4 times 2 is 8. So 84, and we put it right there. 97, yes. And then we do negative 4 times 97. Well, it's going to be negative. 4 times 7 is 28. 8 carry the 2. 4 times 9 is 36, plus 2 is 38. Negative 388. 9 would give us an 8, carry the 1, 3. Y'all can plug it into a calculator and see, make sure that negative 388 plus 29 is indeed negative 359. I believe that is true. So we get this here, yes? Questions on any of this so far? So they're saying to evaluate, yes? Now, we did this differently earlier this week on Tuesday, because we talked about evaluating on Tuesday, yes? So I'm just getting this here so I can, because on Tuesday what we said, I'll clear all that out, is that we would say 5 times negative 4 to the third minus negative 4 squared plus 13 times negative 4 plus 29. This is how we did it on Tuesday, yes? To evaluate a number, we plugged it in, let the calculator do it, enter. Is that the remainder that we got? The remainder that we have for synthetic division will be the same as if we evaluated for that same value. So evaluating it for 4, plugging it in, and doing synthetic division, whatever the remainder is will be what that value is. Yeah. So the answer is negative 359. In some ways, almost evaluating it this way is about as fast, if not a little bit faster, than trying to plug it into the calculator. So for this one here, we bring down the 4. 5 times 4 is negative 10 plus 20 is 20 minus 10 is 10. 5 times 10 is negative 21 plus 50. Well, if I'm adding up, because we need 9 to get to 30, so this here would be 29. Questions on this here? Do we need to see another example of one of these here? We feel good with this here? Okay, I'm going to go back a few. This one here. Now, this here is different because if you notice what we're dividing by, this here is x squared minus x minus 4. It's different than what we had previous. Because all the ones we had previous, we just had x and a number. We didn't have an x squared term, yes? When I was in Algebra 2, whenever we came across a problem like this here, they told us that just do it by long division because it's not a binomial, it's not a two term. Most college algebra courses will just say do it by long division. It's easier to do it that way. It wasn't till a few years into teaching here, I had a student ask, can we do these by synthetic division? My immediate response was no, we do it by long division. I decided to actually look it up and see if we could, and it is possible. It is possible to do this with long division. the first thing we have to do is solve this here for x squared. We have to solve it for x squared. And what I mean by that is just get the x squared term by itself. That's all we need to do. So the first thing we can do here is add 4 to both sides, which tells us x squared minus x is equal to 4. We good with this here so far? X squared's not by itself, so we would add x to both sides. So we get x squared is equal to x plus 4. We have 2 lines because x squared is equal to how many numbers or terms? 2, yes? Equal to 2 different terms, so we have 2 different lines. Now, here, what's going to go inside the cubby hole are the coefficients. So the coefficient number in front of x is 1, yes? And then we have 4. Yeah. 1 and 4. We have those 2 numbers. 1 and 4. 1 and 4. Yeah, you can do a comma. Hang out here, and if they complain, I'll take the brunt for that. I want you to at least see this, so you've at least seen it, so it's not split up. You can put a little dashed line, comma, whatever you want, just to know that they're separate. Okay? Now, again, the numbers that we do across the top, just like we did for the other one, is the same. So we'd start out with 2 for x to the 5th, 1 for x to the 4th, negative 15 for x to the 3rd, negative 2 for x squared, 10 for x, and negative 24. Now, for the most part, this isn't too different than what we did so far. Yes? I mean, besides having now a negative 1 and 4, or sorry, 1 and 4 inside the cubby hole in 2 lines. So we good with this so far? Now, the first thing we still do is we drop 2. 2 is going to come all the way down below the second line. So we drop 2 all the way down. 1 is going to be dropped down. So the first number goes all the way down, the second number goes down 1. Okay? Now we're going to multiply. We're going to do 1 times 2 is 2. We put it right here. We do the same thing also with 4. We do 4 times 2 is, it goes all the way to the top. So the first number multiplies by that bottom one and goes on top of the second line. The second number multiplies with that same number and goes above the top line. Questions on this so far?
Would you still add 1 and 2?
We would add, so 1 plus 2 is 3. And then, Mr. McClendon. Yes, I'm holding on to him just for a second. We're finishing up an example problem. Okay, bye. So we would add straight down and get 3. We'd add here. Negative 15 plus 8 is negative 7. We good with this here? We do the multiplication again. So we do 1 times 3 this time, which is 3. 4 times 3 is 12. Add straight down. Negative 7 plus 3 is negative 4. Negative 2 plus 12 is 10. Then we multiply again. 1 times negative 4 is negative 4. 4 times negative 4 is negative 16. We add again. 10 plus negative 4 is 6. 10 plus negative 16 is negative 6. We do it again. And this is it. 1 times 6 is 6. 4 times 6 is 24. Negative 6 plus 6 is 0. Negative 24 plus 24 is, do I have any more terms? No. Now, what we can do at this point here is bring this last 0 down. And these last two are our remainders. The farthest number would be our constant. This would be our term with x, because our quadratic, we have a quadratic that we're dividing by. So the degree is always going to be 1 less for the remainder. Since it's x squared, we'd have a constant term in x. Now outside this here, the 6 would be our constant term. The negative 4 would be our term with x. Our 3 would be our term with x squared, and our 2 would be our term with x cubed. So what we're left with is 2x cubed plus 3x squared minus 4x plus 6. And again, I'm showing you this here so that y'all can see it, so you can know that it is possible to do it this way. But it is a lot more to it. There's a lot more going on with this. So if you feel, especially these here, it is a little bit easier to do this with long division because we have a lot less going on with all these terms. But it is still possible. Any questions on any of this here? So, page 187. Through 18, 23, 25 through 28.